Hello dear students, welcome again. So let's discuss a very important problem particularly related to organic spectroscopy, that is number of signals. All right. So whenever we talk about number of signals of a particular organic molecule. So number of signal may be of, that is number of signals, PMR signals, proton NMR signals. Next, CMR signals, that is carbon 13 NMR signals, or signal may be depth, you know, distortionless, enhancement, polarization transfer, depth signals. All right. And depth, you know very well according to your own previous knowledge. Yes, depth may also be depth 45, depth 45, depth 90, depth 90, and depth 135 as well. All right, 135. So we can find out number of signals, that is proton NMR signals, carbon 13 NMR signals, as well as depth NMR signal. All right. And this particular problem is very, very important, right? Very, very important with respect to NET, JRF, or even IIT GATE, or even JAM. All right. So PMR signal, okay, CMR signal, depth signal, and another term, yes, involving here is that is, yes, topicity. Okay. So complete problem is topicity and signals. Okay. Just like diastereotopic protons, enantiotopic protons, right? Homotopic protons. So, yes, let's take an example. For instance, let's take an example. Okay. A very famous example is that is alpha pinene. Okay. Overall class is pinene and its derivatives. All right. Pinene, pinene and its derivatives. All right, my dear. Derivatives. Good enough. So first example here is pinene. Second one, alpha pinene. Alpha pinene. Third one, beta pinene. And even one another, that is myrtinol. All right. Myrtinol. Okay. So these are very, very important examples. So let's finish the job with alpha pinene. Okay. Let's understand topicity, that is homotopic protons, enantiotopic protons, diastereotopic protons, and number of signals as well. All right. So yes, let's resolve the problem. So this one is alpha pinene. Good enough. This one is alpha pinene. I hope so you are familiar with the term pinene, pinene. All right. It is quite important problem. So this one is alpha pinene. All right. Having a double bond inside the ring. And in case of beta pinene, exocyclic alkene involved. You know very well. Okay. So this one is alpha pinene. If we talk about the real kind of conformation, so yes, the conformation of this particular molecule is just like this. All right. This one is, yes, alpha pinene. All right. Alpha pinene. Now question arises, how many signals? All right. Whenever we talk about signals in case of PMR, CMR, or even depth, as already told you. Okay. So first of all, number of hydrogen atoms we have to find out. Okay. Number of hydrogen atoms in this fashion. All right. Number of hydrogen atoms. And listen now carefully. Look at it with an eagle eye. Yes, I'm introducing here one term, that is enantiotopic, diastereotopic, or homotopic kind of protons. But in this particular case, yes, first of all, find out chiral centers. Before going into detail regarding topicity, first of all, find out chiral center. Is there any chiral center? Yes, indeed. This one is chiral center. Yes, beyond any doubt, beyond any question. This one is also a chiral center because this carbon consisting four different atoms or groups. Am I correct? So before going into detail, let me remind you one thing. Yes, if, attention, if a methylene group, if a methylene or jam dimethyl or jam dimethyl, jam dimethyl set of protons, set of protons present, yes, present adjacent to a chiral center, to a chiral center, then this type of set of methylene or jam dimethyl is known as diastereotopic in nature. All right, diastereotopic in nature. Is that okay? Remember or not? Right? And whenever we talk about number of signals and gives this set of proton, yes, gives two peaks, two signals or two peaks, whatever you want to say, it doesn't matter, right? Two peaks or two signals. Am I correct? Okay. So by keeping this point in mind, diastereotopic, enantiotopic, homotopic, you know very well, right? Diastereotopic. Whenever we replace a particular hydrogen, right, with other type of, yes, atom or molecule, whatever you want to take, it doesn't matter, right? Then it becomes a new types of chiral center. And there are two chiral centers, right? A new type and the old one. Both are diastereotopic, yes, or diastereomers to each other. Am I correct? Okay. So let's talk about the number of signal. Ultimately, our question is number of signal. So yes, this one is the chiral center and this methylene, yes, adjacent to a chiral center. So logically it is, yes, my dear, diastereotopic in nature. And this methylene set of proton also diastereotopic in nature. And this jam dimethyl group also in diastereotopic in nature. Am I correct? So find out, yes, a set of protons, yes, adjacent to a chiral center. That is diastereotopic in nature. So ultimately, how many signals? Whenever we talk about signals, so yes, PMR signals. Let's resolve it. Yes, PMR signals, total number of proton NMR signals and carbon 13 NMR signals, for instance, right? Then we will talk about depth NMR signals, but later on. Anyway, so let's find out. Okay. So first of all, diastereotopic set. So 1 and 2. Correct. Now this one is also the, yes, diastereotopic topic set of proton 3 and 4. This one is also diastereotopic 5 and 6. All right. These two hydrogens are chemically non-equivalent. Yes, beyond any doubt, beyond any question, due to different neighbors, right? इसका neighbor कौन है? CH2. And what about the neighbor of it? That is alkene. So these hydrogens are chemically non-equivalent. So give different peaks. 6, then 7, then 8, then 9, and then 10. So total number of PMR signals, 10. Right? Is that okay? So you can also resolve the problem of miltinal, right? Miltinal as well. Just try and let me know. Okay. Now question arises, how many CMR signals, that is carbon 13 NMR signals? Okay. Carbon 13 NMR signals. So think about it. Carbon 13 NMR signals, that is much more focus must be laid upon carbon atoms, right? Hydrogen atoms को नहीं देखना है फिलहाल. So yes, let's start. Carbon atom 1. Attention please. 1. Okay. This carbon 2, 3, right? Both are different, right? Then what about it? 4. What about it? 6. And here is 7. All are different. Then 8. 7, 8. Wait a bit. 1, 2, 3, 4. Okay, this one is the 5. Okay. Explained हो गया. Anyway. Yes, please. 1, 2, 3, 4. Here is, that is 5. Here is 6. This one is 7. This one is 8. And this one is 9. And this one is 10. Am I correct? So whenever we talk about the number of signals, whether PMR or CMR, in case of alpha pinene, so ultimate answer is 10. All right. Is that okay? So thank you so much for your kind attention. See you in next very soon.